Good morning. If there was one thing on my bucket list was presenting inside of a ship, I can tick that off. That's great. So thank you very much for coming and giving me your time to share our story around how we built a product to let us deploy to Kubernetes so we can build a product to deploy to Kubernetes. It was kind of an Inception, so hence the name. Just going to tell you what I'm going to talk about today to make sure that we are on the same page. Here I wanted to share our story as how we sold Kubernetes as a service to our customers, but we ourselves ran on VMs on EC2 and AWS. And at one point we had to, and we decided to move to Kubernetes. What did we have to do? How we went out shopping for tools and open source projects to use this. What did we come up with? What did we build? And what did we open source back to the community and share our story? So I'm not demoing anything. I'm not going to give you like a single point. There's no silver bullet. It's just a story of what drove that transition and what we had to do to get where we are now. And hopefully that's going to be useful to you. I'm available for questions afterwards as well if you have any specific cases. So let's begin. This is what our stack looked like. To give you a little bit of context, Cloud 66 is a SaaS product. You can go to cloud66.com. If you are a customer, you log into our account, you connect us to a Git repository on one end, and you connect us to a cloud provider on the other end. And we act like your own Heroku from outside on your own server. Right. And this is what powers that. So traditionally, from about 4 years ago, we ran on Ruby, on Rails, all the sort of stuff. We have then a bit of a Node and some Golang as well as that. And there's MySQL, Memcached, Redis, you know the drill. And this was running on AWS EC2 instances. And it was working fine. It was completely fine. We scaled to about, I think, somewhere around 800 companies, say about 7,000 developers using it day to day. It would deploy stacks for our customers about 5,000 to 6,000 times a day. Everything was working fine. And we developed a very sophisticated deploy pipeline for ourselves. Because if you have customers in 120 countries, there is no nighttime. There is no maintenance window that you can go and say, I'm going to shut everything else down and roll up things out. And when you're building a stack for your customers and every job takes 20 minutes to 2 hours, imagine if you're doing 5,000 of those jobs, there is no quiet time. Every time that you get into a server, something is doing something. And therefore, we had to build a deployment flow that would build everything while service is 99.9999 are up. So everything was working. We had a very good system. And one day, we had one issue around search. If you can imagine, what is an inventory search for an infrastructure? You want to have an omni search bar, like a Chrome, a single search bar that you want to go there and say anything you want about your infrastructure, and it comes up with a list. If you enter an IP address, it tells you what server that IP address is, and it tells you what firewall rules it applies to. If you enter a name, it could be a tag, it could be a server name, a cloud provider, or firewall. So we wanted to build a search capability for our SaaS product. That's what we wanted. And if you do it like us, we do something very small, and we would do a prototype, and then we just improve and iterate. So we went and did this on MySQL. We did the search of all the entities that you can search on, and we returned every result. But it wasn't performant. So one day, our devs said, we need a proper search system. We need Elasticsearch, Lucene, Sphinx. And they settled on Sphinx and said, Sphinx, great. We're just going to import everything we have onto the database as documents into Sphinx, and we're going to give people search. And they built a prototype that was really fast, efficient, worked like a charm. It was great. And then when it came to roll out to deployment and to production, they went to ops and said, OK, so we need Sphinx. It needs these ports, and it has these things. And the ops went, whoa, 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 whoa. What are you talking about? How do I make this high available? How do I back it up? How do I migrate? How do I deploy a new version? What do you mean you want a new port open? Who's going to access this? What are the security vulnerabilities? And that got us thinking. We've been building Kubernetes for our customers for a while, so we thought, why not get our ops guys build one thing, a Kubernetes cluster? learn how to build that in a secure, scalable, highly available way, and then let developers do whatever they want on that cluster. So ops guys can just do one thing and they do it really great, and developers can just deploy onto the cluster without any issues, without having to have these conversations every time. And the journey is started. Obviously, the first step was to build a Kubernetes cluster. And this part is fairly easy. Nowadays, you can go to GKE and clickety-click. You have a Kubernetes managed cluster with as many nodes as you want across different regions and geographies and data centers, and it's great. So we had our Kubernetes cluster. It was great. We had everything. We were running on cloud. And we thought, OK, so let's go shopping for a deployment pipeline that can take care of this for us. So this is to distract you, so I can say things. But when you're back, I'm here. So we went shopping to find open source tools, companies, vendors, anything that can help us take our application that you saw the stack of, deploy to a Kubernetes cluster that we already had. And the first thing that came to our mind was, our CI is going to do it. I mean, we have a CI. It takes the code, it builds it into images, it runs the tests. It can just do a deployment. I mean, after all, CI, if we are honest, is a glamorous bash file, right? It does 1 after 2, well, 3 after 2, 2 after 1. It does steps. And we are developers. We can do anything, right? It turned out it wasn't really the case. So we had a very simple shopping list. What we wanted was, first, understand the deploy dependencies. We have different teams working on different things. The search team, the API team, the admin team, the billing team, not teams, but services. And while we take really good care of doing contract-based development, so when the API is bumped up, the web doesn't break, and they don't have to talk to each other if they don't want to, but sometimes it happens. So we needed to know the dependencies. If something goes up, we need to deploy other things. And sometimes you have to deploy things at the same time. For example, there's a security vulnerability. You need to update everything because the base image has a vulnerability on it. The second thing we wanted was deploy the entire stack in minutes. Now, there was a time that you could build a stack in like a month. I used to work in a bank, and it was like 6 months to build a new environment. But when you can do the whole thing end-to-end, soup to nuts, A to Z, with one click, why not? I mean, it's great, right? You could have an environment for every PR, for every tag, for every branch, for every customer, for every feature, for every developer if in the team. That should be possible. And the third thing was, which might be a bit specific to Cloud 66, is that we are a SaaS product, but I lied when I say that because we also sell on-prem. We have big banks who buy Cloud 66 and put it on the right side of the firewall. And we wanted to have a deployment system that works for both. So it turned out it's not as easy. So the challenges that we faced were kind of like this. First, we faced 3 challenges. 1, secrets. Now, I look at secrets as configuration. I mean, technically, they are just part of configuration. They're just a bit sensitive configuration, like passwords. But technically, they are configuration. And you want that configuration to be in lockstep with your code. There is no sense if you introduce a new search feature or a new Redis, for example, that your developers want, and you roll it out, your code is out, and the configuration for that Redis needs approval for a PR from an ops guy to go out. They have to go in the same pace. That's the first thing. The second thing is configuration should be version controlled because you want to roll it back. You might want to improve something and see the impact of scaling something up or down. And the third part is, and it's specific to Docker, is that sometimes you need secrets in order to build the images. So what does that mean? I think they're building a container. If you've used any of the modern programming frameworks like Ruby or Go or Node.js, you're familiar with Ruby gems or NPM packages or Go Get. And you see sometimes when you do a Go Get, for example, or npm install, you need a secret, an SSH private key, because one of the dependencies lives inside of a private repository. Now, it could be because you have used the open source version of a library, and then you paid, or your company paid for an enterprise version where it needs a private key. Or it could be that it's just one of your own dependencies that you put it, you haven't open sourced it yet, and it's somewhere. So when you do a Docker build, your secret needs to be inside of that Docker build daemon to run it. And there was nothing out there for us to help back then when we wanted to do it. So we set out to fix that problem. For the first two, the secret part is OK, because you can use something like HashiCorp Vault, which is great. We were not using that back then. It didn't exist, but that's beside the point. It's great, and it's here. The second part is a bit tricky, because how are you going to put your secrets in a code repository without exposing them? If you put it in the Git, it's there forever. If you encrypt the file, then you lose the benefit of Git, like diff and versioning and all that sort of things. And there are solutions out there that allow you to just encrypt the secret, not the key, and still keep, for example, the YAML file, the YAML. SUP from Mozilla is one. Nox from Pinterest is another one. Go and check them out. They're really great. Allow you to do that. And that helped us through the first step. But there was nothing for us to be able to build the images with secrets that we wanted. The second issue, are you fans of Fast and Furious? This is a great scene that's really, really relevant to this. The second thing is this. You remember that conversation between devs and ops? The devs go and say, give me one thing, make it high available, make it scalable, back it up, put it on all regions near the customers, and I'm going to use it. It turns out that Kubernetes is like a vending machine that operators build for developers, right? They build it, they power it up, they make sure it's always stacked up with cookies and candies, and developers just go and use it. There is a problem, however. And sometimes, if you've seen this scene, that there's the vending machine blows up after this. I didn't find the animation for it. Sometimes the developers can put a coin in the vending machine and make the corkscrew go backwards or blow it up. This is not possible with a vending machine, but we know with Kubernetes we can do that, right? You give me a Kubernetes cluster, I can commit a very, normal change that will bring everybody else's application down because they just messed about with the ingress or, I don't know, introduced a new persistent volume type. So we wanted to eliminate that mistake. We wanted to make sure that that doesn't happen. The third issue that we had was we found that environments are not adequate anymore. Remember when we have an environment that you can build in 6 months? That becomes precious. Nobody's going to dare to say anything. I used to work in a bank, and we had UAT environments, user acceptance testing environments, and we had a lot of money, so we had 2 UAT environments, UAT1 and UAT2. And we had staging, and we had production. That was amazing. Now, if I can deploy the entire stack end-to-end into a namespace in Kubernetes, why not 3? Why not 300? Then what is environment? What am I going to call it? Staging 300? And what am I going to do with the configuration? If I have username, password shared across all my productions or all my UATs or all customers, that's not going to happen. So what are you going to do with the configuration? If you're familiar with the products like Rails, like a framework, you have a configuration file per environment. That's not going to cut it anymore. So we had to invent a new concept, and we called it formations, which we get to later on, that would help us, that supersedes this environment thing. OK, so 3 problems, and we set out to solve those. And we open sourced 2 of the solutions, and we built a product around the third one. The first thing is Habitus. Habitus is an open source project. It's fairly popular. It's part of CNCF as well. You can go and check it out at habitus.io. What it does is it is a command line tool that can run as a service, as a daemon as well. That does 3 things. 1, it builds your Docker build, builds your images in a workflow step. Build 1, step 2, step 3. And it does it in a way that you can run it on your own CI. So if you're running on, I don't know, GitLab or Circle CI, you can use Habitus with those guys because it doesn't need to know what the structure or infrastructure setup of Circle CI is. If you run parallelized deployments, for example, builds on Circle CI, it might be that one of your builds happens on one server and the other one happens on another server. And if you want to take the artifacts from one step and put it into another step, they might not work, depending on which CI solution you use. Habitus can handle that. The second thing it does is that it squashes the images, so it takes out the layers that you want to take out. If you just put some, I don't know, package there, or you put a secret there, you can take it out, and it reconstructs the Docker image for you. And it also moves the artifacts. Now, in the previous talk, if you were on the ship, in the previous talk, there was a talk about images that are big and fat and they have all the developer dependencies, and images that are small that are good for runtime. Now, you want to have both. You want to have a fat image that you can build and has all the dependencies, like building of image processing libraries, but you also want to run it on a small one. Habitus can take one build from one image, take the artifact out, compile it, and put it into a small image that has a less and a smaller attack surface, and it actually is much more efficient. And it also has a secret server. So it can serve you with your SSH keys with anything else within the build flow. So you can do go get or npm install or Ruby bundle install where you can actually use it against a private repository. That's Habitus. The second tool that we built was Copper. Now, Copper is a validator for Kubernetes configuration files. So here's the 3 examples that are inside of the file, but I'll tell you one about the one outside as well. So the first one that you see is there. It's a very simple DSL that it's got. It's a command line tool that you can just run on your laptop or on a build server. It understands the construct of an image, a Docker image. So in the first one, it says, don't use latest. Don't let anybody use tag latest because that's bad. That's bad practice. And it understands that if in a Docker image, if you don't have a tag, Docker assumes it's latest, so you can rely on a Copper to take care of that for you. The second example is, my ops guys let me bump up my SQL by a minor version, but not a major version. So if I want to do from 5.6 to 5.7, that is going to give my ops guys an alert. But if I do go from 5.6.1 to 5.6.2, it's all good. It allows you to do those things. Or the third example is, any IP address, for example, it understands the concept of IP address. Any IP address that you use, for example, for your load balancer should be within this range. Now, we built this because of the vending machine issue. Now, you might say Kubernetes has RBAC, role-based access control, where ops guys can lock it down. But when you talk about these repositories that you want to push the code and the configuration out at the same time, then it means that every developer who goes and does something like changing a configuration file for Kubernetes has to wait for the ops guys to vet everything, do a pull review and a review, pull request review and everything else for it to be signed off, and we get to the same conversation. So by all means, have RBAC on Kubernetes, and we do as well. But you can use Copper as well. It's open source. You can check it out in Copper SH. It's free. And so we thought, we figured it out. It's all great. Such a big fan of Simpsons. You can tell. But there was more. The next issue we figured out was service dependencies. And I talked about it a little bit more. But if you go on DigitalOcean blog, there is a great blog post about whether you should choose a monorepo or a multi-repo. And what is a monorepo, multi-repo, for those who might not be familiar with the topic, is that if you have broken your application into, say, 20 different microservices, where would you put the code for those 20? Would you keep them in the same Git repository, i.e. a monorepo? Or would you break it into 20 repositories? Or if you use Git, which you hopefully do, would you put it in submodules? Each one of those approaches has its own pros and cons. If you use a monorepo, it's great, but if you mix 2 languages, you might get into trouble, like mixing Go and Node. Then you have a package JSON, most probably, that's going to cause issues. If you use multiple repositories, then where would you put your configuration? Would you nominate one as the chosen one that's going to have the configuration? Or would you have another one? And if you choose another one for the configuration, then how are you going to make all of them go at the same time? So our solution, we ended up with a monorepo for most part. But we also have a separate repository that holds the configuration. And we had to build a product around the whole thing to make sure that my configuration and the code go out at the same time. Now, this is going to be fun. How many people use Helm here? Great. You're not going to like this. No, I'm joking. Right. So we started with Helm. We thought, we got a bunch of things that we want to do, and this all started very innocently around here. We had one file for 20 services, all of them identical. Why write 20 service YAML files? Why not just use one? Use a templating language like Helm. I mean, this is a mock-up. And repeat this 20 times. And this way, if I want to add another environment variable, I don't need to go around and sprinkle it around in 20 different files, right? Right. Somebody said, well, hang on, but web is different. Web is the only service that we expose externally, and it needs a fixed IP address because we have a DNS record pointing to that global IP address. You cannot just, change that IP address. The DNS is not going to propagate in time. Everything's going to go to shit. So, did I just say that? So then this happened. And it was kind of OK. And then something like this happened. If you look at the ports part, someone said, your team has between 6,000 and 7,000. You're not going to just introduce a new port into this thing because it might conflict and everything else. So you have that one. If you don't, we have this global port map that you're going to choose from based on the service name. So what happened was this. We ended up in a mess. Why? I think the answer is simple. If you look at this, this is Go's templating language, but it applies to pretty much any markup, markdown, whatever you want to think about it, Arab. The thing is, those scripting languages are written for HTML. HTML not only is not as structured as JSON or YAML, but it also has a lot of tooling around to make sure it's proper lint and everything else goes with it. And we started using a HTML-based templating language for structured data. Imagine doing this in JSON. Now you're going to go insane. Now, YAML, space tab, 2, 4, that's insane. Doing this with it, good luck. So that was our second issue, the second time round. We started with this, and as I said, the first round we went out, deployment went fine, everything was OK. We went to Kubernetes, everybody was like high five, and then a month later we are here. So what we made the decision, and this is for Helm fans here. I'm a Helm fan myself, but we decided that horses for courses. Helm is a package manager for Kubernetes, and we use it just as much. If you want to deploy RabbitMQ, we use Helm. If you want to deploy Redis, we use Helm, because no way I'm going to be better in writing a scalable RabbitMQ script to deploy in Kubernetes than somebody who's written the chart for it, right? But if it's my application, I want to be in control. So we invented something, we just took out some control flow out of this, and we called it stencils for our own application. Now, this is on the deployment workflow side. Remember when we thought about CI is going to cut it? Turns out it doesn't. Because CI does, step 1, 2, 3, 4, and stops the flow. And some of them have some manual interjection points and stuff. Oops, sorry, that was a bit clumsy. But there are one-off things that you want to do. For example, database migrations. Now, if you follow best practices, you make sure that your database migrations are backward compatible. They're not going to break anything, but sometimes it happens. Sometimes it's inevitable. We've been very good at discipline in this, but sometimes we have to shut down everything or put it into read-only mode, not only because it's not backward compatible, but the database migration, adding an index to 1 million row table is just going to take time, and it's going to be, at 15 minutes, that database is kind of in a funny state. So those are the one-off things that the CI doesn't cut. The second one is rollback. Sometimes you want to roll back. How are you going to do it with the CI? You have to build a hefty bit of machinery around that. And then there are these fancy new, I'm going to use fancy and new, ways of deployment, like blue-green, red-blue, red-black, canary, A/B testing, gradual, incremental, whatever you want to call it, around it. And CI is not very good at that. On the workflow side, sometimes you have these formations or environments, but you want to say everything is good with UAT, everything is good with staging, I want to promote it to production. How are you going to do that with a CI? Again, that's another challenge. And the last part is approval for manual approval. Sometimes you need your customers or clients' approval. Sometimes you need another team's approval. And we found out later on that it's just putting something on a Slack channel is not going to cut it, because people get about 533 Slack channel notifications every minute, and they're not going to check the one that's just scrolling at the speed of light. It says, oh, you changed that? Oh, I missed it. So that was not really good either. We looked around and we found Spinnaker and GitLab CI/CD tools as well. Spinnaker was too big because it takes care of much more than just deploying to Kubernetes. It takes care of like security groups and all that sort of stuff. But by all means, check it out. It's really good. And GitLab, Mixed feelings about this. We are not running on GitLab, so we could have moved out of GitHub to run on GitLab to do this, but GitLab is, at the moment is a CI tool, and we decided against using it all together when we had to do a lot on top of what was there. So this is what we built. We built Skycap Container Deployment Pipeline. That's a long name. And it starts like this. On the top, you have source code. We run the unit test with Habitus. Then we get it to building part, which we do with Habitus and build steps if you want. And on the Docker images, we do retagging. And that's a kind of an interesting point, because even if we go to a repository to pull out, for example, Redis image, we wanted to retag it every time we do a deployment. We don't want to just use, Redis 4.1. We want to make sure that every deployment that involves that component, even if it's not ours, has the tag. And not only does it have the tag, the container and the pod that goes out to Kubernetes with it has annotations so we can trace everything back to see where it's come from. Once we do that, then we store it in repository. Skycap comes with the repository itself, a Docker registry, I should say, but you can use JFrog or Key.io. And then after that, we would run Claire or Twistlock to make sure that the images we built doesn't have several things, security vulnerabilities, and doesn't leak our IP if it's a public image that we're going to push out somewhere. The next step for us is integration tests. So we fire up everything end to end, including databases inside containers, for an integration test, and we hit it on the endpoints that we want, and we get the 200s that we want. Everything's good. And then the next step is building the stencils, the same templating thing, alongside Helm for the things that we use Helm for, to generate the configuration and roll it out. And then after that, we use Copper to make sure everything is kosher, everything is according to what it should be, and everything is based on the templates that our ops guys say we should be doing. And there is one thing here. So when you talk about something like Helm or something like stencils, it is specific to that component that you're deploying. If I go and write a chart for Helm, or if I go and write a stencil for whatever component that it is that I'm deploying, it's specific to that. What Copper will let us do is something that we call base templates. So my ops guy can come and say, if you want to deploy a service or an ingress or a persistent volume class on Kubernetes, this is how the template should look like. It's not specific to this service on this application, but then I have a library that I can drag and drop and say I need 5 services, and all of them look the same with the slight differences without having these loops. And you can check it out on Skycap. And then the normal stuff about deployment workflow, configuration management, manual workflows, and then it hits Kubernetes cluster with the feedback to make sure everything's gone right. So the second round of challenges we had led us to, again, 2 open source projects and 1 set of new features inside of Skycap. The first one was gifnock. So gifnock is config turned on its head. Now you get it. And what it does, it is a configuration tool that takes care of secrets, but not itself. It takes care of secrets using Vault or KMS from Google or Amazon. But what it does is that you can have shared configuration between different formations. Remember when we had like 1 production or 1 staging, and we said we're going to have to end up with like 300 staging? It turns out that some of the configuration, a lot of configuration parameters alongside those are similar, like the phone number for the company, if it's a configuration thing, it's not going to change. But some things like the IP address might be different. And those are the things that we have to store in gifnock. The next one is the stencils, which we talked about, against things like off-the-shelf Helm charts. And the GSR is a global service registry it's like a service discovery for things that are not inside of a container. So you have S3 buckets, you have firewalls, you have security rules, all those things that you want to discover, you do it with GSR. And that's another open source, that's going to be open sourced. Now, quickly on to why we did that is that we realized that complexity needs a home. And every time we wanted to build something like a key value store to store like the names of the S3 buckets that we have, we realized that we need to have something like a gossip algorithm based on a consensus 5-node election leader thing for it to be highly available. And we stepped back and thought, well, hang on a second, we're running on the cloud. We're just going to get Redis as a service, put it on App Engine on Google, and we have a highly available thing. Why are we thinking about that again? And that's what we did with GSR. So GSR is essentially a key value service that runs on App Engine, Google App Engine, backed by MySQL, in Cloud SQL, and it gives you a key value storage that you can store things that are used across all your clusters, like S3 bucket names or IP addresses for build servers. So what's next? Next for us is to build something like Istio or use something around service mesh, but for async workloads, that we can have version 1 and version 2 of a queue as opposed to just HTTP requests. Sometimes we make different changes into different formations, and we want to make sure the second part is to compare those formations to make sure when it goes to production, it's not going to break something. So the comparison between different formations, and integrating GIFNOC with Vault itself is a third part. That was it. That's what I wanted to talk to you about. That's what the story was, kind of a very fast-paced thing about everything we've done. So I think I've got a couple of minutes for any questions you might have around this, and thank you very much for your attention.